We will begin this morning with two keynote presentations to help set the stage. We'll begin with Dr. Cyrus Wadia. Cyrus is the Assistant Director for Clean Energy and Materials Research and Development with the White House Office of Science and Technology Policy, where he advises the Executive Office of the President on federal policy to accelerate innovation and deployment of advanced materials systems for energy, national security, and human welfare. While at the White House, Cyrus is on leave from Lawrence Berkeley National Laboratories and the Haas School of Business at UC Berkeley, where he holds a dual appointment as a research scientist and faculty and co-director of Clean Tech to Market. His research in both exhaustible resource economics and the aqueous chemistry of nanoparticles is motivated by the pursuit of new, low-cost energy technologies using Earth's abundant materials. Cyrus has been the White House leader for the Materials Genome Initiative and is its ambassador to the materials science community, to us. He will speak to us today about the MGI and the critical role of materials and manufacturing in global competitiveness. Cyrus?
Thank you, Liz, Warren, for all of the leadership you've provided. So I really appreciate the invitation to be here today. This has been a very exciting year for us. Thank you for the kind introduction, Liz. And again, reiterate Warren and the rest of the TMS team, some of our interagency team that's here in the audience. Just quickly point them out: Julie Christodoulou and Jim Warren, Julie with ONR, Jim with NIST, Chuck Ward with AFRL, and Kathy Stevens with AFRL. I think I've captured everyone, but I'm here to really represent truly an interagency process and group. So feel free to come up to any of us during the course of this summit to learn a little bit more, give us your ideas. I am going to start with a video address from Tom Khalil. He's the Deputy Director for Policy at OSTP, and many of you may know Tom. Tom is, he has been really sort of the behind-the-scenes person on Materials Genome with respect to navigating the waters of the White House and the federal bureaucracy to get a lot of the things we've gotten done faster. So I'm really excited to have him provide some remarks. He would have liked to be here in person, but it's a short video address, so why don't I start that, and then I'll get into the bulk of my presentation. That was a really nice lead-in, and then I'll spend the majority of my time going through the details of the initiative, but I want to fill in a few gaps that Tom didn't necessarily get to in his remarks, and that is since taking office, this administration and this president, it's been the policy to, you've heard this before, out-innovate, out-educate, and out-build our competition. And we believe efforts in advanced manufacturing and advanced materials, like the Materials Genome, really touch on all three of those themes. In this 2012 State of the Union, the President called for, and this is all hands-on-deck type of call, for an expansion of high-tech manufacturing capabilities and jobs in the U.S., for the U.S. to stay on the bleeding edge of innovation and technological advances, and for the U.S. to expand its skilled employment and training opportunities for an American workforce. And so in the spirit of those three items, again, the Materials Genome was really created, inspired by that, and also inspired by many of the companies that are here today and others that couldn't make it. But I want to reiterate what Tom said, reiterate some of the remarks this morning, that success of the Materials Genome Initiative does not depend squarely and solely on the federal government and what we'll be able to accomplish, but on your thought leadership. And really, through your interest in this, through your action, and in the years to come, we really believe this is going to grow well beyond just a federal R&D exercise into what we're calling a national movement. So let me first start with an example. And we have Jerry here from Boeing, so I'm going to embarrass him with probably some misinformation. But this is the Boeing Dreamliner 787. And the reason I'm showing this to you is because it really captured the attention of President Obama roughly 4 weeks ago when he visited Everett, Washington, where he visited the facility, made some remarks on manufacturing. And so we were all excited that this is, got a few fun facts: 50% carbon fiber, 20% more fuel efficient. I think 1 to 2 orders of magnitude fewer fasteners. The list goes on and on. A lot of this made possible by the fact that we're moving to these composites, these carbon fibers. And of course, the touch windows, I'm really excited to see that at some point, Jerry, but the electrochromatic shading. But I think it's a cool plane, and that's kind of what the president said, but really what is even cooler is how they made it. And this is exercise in virtual prototyping. They had a global supply chain across the globe, I think more aggressive than any previous airplane, and they were able to trade off costly and time-consuming physical experiments for materials modeling that allowed for thousands of iterations versus the normal 1s to 2s that the normal airplane process goes through. So I think what we learned from this is that you could be hosting a supply chain that's across the globe, this network. A change might get made in Japan that's immediately seen in Everett, Washington. And even though we can't speak directly about the time compression for putting this new airplane into practice, into the field, we can speak to the number of new designs that they were able to go through, and a 20% savings in fuel efficiency is quite remarkable. There are other aspects of this that go beyond just the technology and the process, and what we're here to talk about, the materials and the manufacturing. But Boeing, I believe, created 11,000 new jobs in the U.S. They have a supply chain that's supporting this airplane that's hundreds of thousands of jobs, and they're currently the #1 U.S. exporter in terms of dollar value. So this is the type of activity that we think really speaks to the materials genome, and I hope to give you the breadth of what this materials genome initiative is about, but I think we can all take a page out of the Boeing book. When we launched the movement last year, we recognized that, and this is the speech that the president gave at Carnegie Mellon last June, we recognize that advanced materials touch on all parts of our lives. It's not just about airplanes, but clean energy, national security applications, human health and welfare. Really, this initiative is about capturing the imagination of all these material categories. And once we flip through these, I think that what most people don't realize is that it could take 10 to 30 years to get a new discovery to market. So this is a slide our colleague Harriet shows, Harriet Kung from the DOE, borrowed from Garrett Sater at MIT. But it doesn't matter whether you're talking about lithium-ion batteries or Teflon or really anything. It's consistent that from the point of discovery through deployment, there is about this 20 to 30-year time frame. So our tagline and vision is very simple: twice as fast, twice as cheap. But we're up against many barriers, as many of you are familiar with, being from the materials community. This is a fragmented community. We have over a dozen different professional societies representing the materials community, and in some ways it's very siloed. Secondly, there's no incentives so far, no large incentives to form tighter collaborations or share information. And lastly, there's really no infrastructure that enables the type of ecosystem that we're driving towards on a national scale. So we talk about this being a movement because this is more than just a federal initiative. This is going to require a culture shift, a change in the entire community, and of course, like I mentioned earlier, leadership from the entire community. So I just said that we're looking at this tagline of twice as fast, twice cheap, but now I can sort of really distill this down into some more bureaucratic language, which is the 4 cross-cutting themes that our interagency effort has been looking at. And really quickly, the first one is on open paradigms. So this is incentivizing open paradigms of sharing and access of tools. I'll go into more detail on all of these a little bit later, but I just want to highlight all 4 for you. The second is on the ecosystems, facilitating the development of innovation ecosystems. Now, this is more than just universities and large Fortune 500 companies coming together. We often make a point that small, medium-sized business who are understaffed, under-resources, also have to be part of this discussion. The third point is driving the innovative techniques across the areas of computation, informatics, and experimentation. So it's one thing to say we're going to go after those and try to bring them all closer together, which is what I'm about to say. But it's another thing altogether to say that individually we have to get better and stronger at each of those components, and that is true. And we often say that the center of gravity of this initiative is really at the middle of all three of those with an equal balance, but we are starting from behind in particular in data informatics and computation. So we need to go a little bit faster on that. And then the last is on catalyzing a shift in culture across the entire what we call materials continuum. And how do you scale this type of movement? So this is a diagram we use in the white paper that really speaks towards the continuum from discovery through deployment. And I thought it worth a few moments to lead with this before I get into the details of the infrastructure I'm going to talk about. But the first thing I want to say is that there are different bottlenecks for different materials and industries. So last night we were having a conversation about certification. I have other conversations with folks on discovery and others on the deployment and manufacturing. So there are clearly bottlenecks and delays and lags at different parts of this 1 through 7, and this is, we can break this down even more granular. But the second thing is, if you look at this continuum, it's necessarily linear because every step along the way introduces new technical risks, new financial risk. The whole process becomes a little bit burdensome. And right now, if you look at this spectrum, there really isn't, at least as far as we can tell, a very good feedback between what's happening on each of these different silos. So the information flow is not ideal. So for example, we talk a lot on the discovery side, for example, of screening for new battery compounds. We believe higher energy density is the key that will unlock all these electric vehicles that we hope to have on the road. But screening them at the atomic level is one thing, but really the problem may happen at more of a macro scale when you think about the durability of such a battery. And it's more related to the charge and discharge characteristics due to crack formation and growth. And so when you think about that, something that's occurring at these larger scales doesn't always filter down to the folks at the bench trying to make these discoveries, and we have to get better at that. So I think that what my point is that there may be a disconnect between what's happening from an innovation standpoint and what's happening in the market. So there are three ways we can compress this time frame. So if our goal is half as or twice as fast, we think that, number one, it's data information flow. So across, back and forth, plus better feedback within the silos. The second is on stronger computational capabilities. So kind of the virtual prototyping that Boeing went through, doing more modeling and simulation, everything from that down to ab initio type of calculations. We just need to get better at that to begin replacing some of these costly and time-consuming experiments. And then the last is what we call an integrated approach, a more intelligent design, and that speaks directly to the ICME community in terms of an integrated approach to how we go through this. So what we proposed in this initiative is a materials innovation infrastructure. So I'll spend a few moments on this. Right now, if you look at this type of diagram, where the federal government is going really strong is in the middle. And we're looking at developing this type of infrastructure. And we hope that in this outer ring, we get the type of outcomes that we desire, both in terms of actual material applications and also a next generation workforce. So in the center, we have computation. So I've already said, how do we replace costly and time-consuming experiments with and validate some of our computational tools, but using the computational tools to advance this. But it's not just that. One of the programs that just came out of the DOE that was announced a few weeks ago is on these computational centers. Tom mentioned it in his video remarks. What they're trying to do is actually quite interesting, that they're trying to bring more software discipline around these models that we often take for granted. So if you're looking at some DFT type calculation, often it's sort of one-offs. We develop it, the code's there, but some proprietary version of it is what you're using, or if you're in a university, it's done by a postdoc and it sits on a shelf. There's no longevity, and we need to bring longevity to these computational tools for it to be successful, and a lot of that might mean we have to start looking more at how the software industry, like the enterprise software, Oracle, Microsoft, et cetera, how they do their business, and bring that to the materials community. So it's bringing the material scientists and the software engineers closer together. The second bubble here is on experimentation. And the experimentation is, in many ways, a little bit further along, but there are a lot of things that we are really behind on. And what comes up a lot is analytic tools, characterization. How do we actually bring better metrology to the manufacturing process so that we're developing these elegant nanoparticles like Jim was talking about last night in his remarks, but when we manufacture at scale, we don't necessarily have the tools right now to identify the imperfections at that scale that we've just kind of worked really hard to develop. So we need those techniques, and we're focused on that. We'll also talk about design principles and figures of merit. So the battery example, how do we bring more of what is relevant to a commercial product into the lab? But the last piece really is on the data, and that I believe is the linchpin in all of this. And we often say in this administration, we've said over and over in many different fields that data and transparency will encourage both innovation, cross-industry, and multidisciplinary work. So creating this more open collaborative environment might start with the data. And there's no set pathway here. We have a lot of work to do. And in many conversations, we are misunderstood to say that we're trying to get everybody to open up all of their data and put it out there in the ether. That's not what we're talking about. But we have to come up with some flexible models where companies with their supply chain have an opportunity to interact, where federal labs and industry have an opportunity to share information more facilely. It's amazing that we have this wealth of information. We're in this information age, as we kind of alluded to last night, and somebody remarked, maybe it was Jim, it was AJ, but that materials are now in the Facebook time, meaning that we're creating these materials very quickly, and sometimes the bottlenecks aren't necessarily in how fast we can discover, but everything that happens in that value chain after. So if that's true, then individual companies like the ones here, you may not have the resources or capabilities to even host your own information, let alone spawn out and help host others' information. This is potentially a classic role for the federal government if we can figure out what that means. So, but that really cuts across everything. So the data brings the computation and the experimentation closer together. The data allows the models to talk if you care about multi-scale modeling. The data is all about integrated computational materials engineering if that's your passion. And then the last piece here is on the workforce. So we always say that success of the initiative can't be measured by the tools alone, but rather by their use. And we have Greg with UMC here in the audience, and he's focused heavily on helping us think through how we engage with universities and how curriculum changes are made. I think that that's a really big start. But again, if this was an audience, a broad audience, what we'd want to say is that we want to change the way people think. Instead of thinking of themselves as just individual researchers, we want you to feel like you're part of this powerful network, collectively using and analyzing data and tools developed by the broader community. So I went a little long on this picture, but this really is sort of the key to our effort. And I think that once you layer on the continuum that I brought in earlier, there's one last piece that I have to discuss, and that is we can't think of applying our infrastructure to just one slice. This is a really difficult visualization to automate in PowerPoint. So that's why you're getting this funny-looking thing. But the only point here is that there are going to be specific tools and infrastructure needs at every point along the way, and we recognize that. But it's going to have to be cutting across the entire continuum as well. So this is a very ambitious program. We're trying to help every step along the way, but also keep it integrated. And if you think about the ICME approach that I think most people here are familiar with, when we draw the picture, we draw it like this, that if you can now take that continuum, wrap it on its axle, plus have the overlay of all these infrastructure components, you do have an opportunity to get more materials out faster. That's the thesis we're going in at. And I think that thesis was developed by a lot of the folks here in the room, so I don't think there's going to be too much debate, but how we get there is really still an open question, and we need your help. We absolutely need your help on this. So let me just conclude by kind of talking about where we have been and where we're going. In terms of accomplishments to date, the President announced the initiative last June, and I'd say we're tracking pretty well relative to historically other initiatives as far as what we're able to get done so far. The federal government has put 5 solicitations on the street, so we have some seed capital going into this. This is just priming the pump. Now, there are modest dollar figures, but it's helping us get things moving. And right now we're already working on our fiscal year 14 budget. So I'm not going to get into that because I know the theme of this is what can you do without our help. And so we do have a little bit on the street that you could look at. We have a long way to go, though. The second point is we're going to spend a lot of time over the next year, and we have over the last 9 months, leveraging on existing federal programs. So again, one of the things I haven't mentioned yet is that we're not trying to develop this monolithic effort. We're going to do things in a very decentralized way. And to be successful, we think that there's a lot of activity, good activity happening across the federal government on different aspects of what we're trying to achieve. So instead of trying to bring them under the tent and sort of kind of show them the MGI religion and say this is now who you are, we're going in a very different direction where we want them to connect to what we believe is important, and we can get higher leverage on our existing programs. Third is interagency coordination, and this may not mean a lot to folks here. Maybe it means a lot to some of you who've spent time in D.C. This is extremely important, and we have an extraordinarily talented group in our interagency. It's well-functioning. It's been just a real pleasure for me to be part of. But this creates our standing presence that, in the ebbs and flows of different administrations, we are working really hard, at least over the next 9 months, to make sure that we get escape velocity and we have something that lives beyond this first term of this president. But that interagency coordination is really important, too, when you think about how we as a federal government move lockstep together. So there's a little bit of hand-holding right now where we talk about the vision, the activities that are happening in the different agencies, what activities are not happening. How do we as a federal government collective set certain milestones that we can all work towards? We're developing those plans as we speak, but we've come a long way already since the announcement. External stakeholder commitments. Tom mentioned a few happening at the universities right now, and we've had several. We've had really just an outpour of support from this community, from the professional societies, from universities, letters of support to the president. Things like that really do matter. And then the last I'd say is partnering with NGOs, professional societies, et cetera, the Advanced Manufacturing Partnership. We've gotten off the ground trying to begin connecting to these folks. Jack mentioned from the council that they're looking at issues like this. Warren has been extraordinarily helpful and active since the beginning of this initiative, even before the beginning of this initiative. And so, again, we couldn't have done it without them. We can't do this without you. And so we have to continue building that relationship. So the last point is on the achieving the vision is where we're heading. So over the next 9 months, this is sort of a sneak peek at what I'll be heavily focused on, and that is working with the interagency to roadmap, create our milestones, to think through the policies and the R&D activity that's going to make a difference, where we have a unique opportunity to support the community. Second is we're going to use our convening capabilities to bring your input into the process. And this is an example where TMS is using their convening opportunities. We are planning a kickoff, a federal government type of workshop that's going to happen in late May timeframe, so maybe you'll hear more about that in the coming weeks. But this is really important because for us, we've said from the beginning, we don't have all the answers. This is an ambitious movement and vision, and we need your input, and no shortage of input at this stage of the game. So the third is focused on industry-initiated commitments and activity. That, I think, is a lot of what this discussion today is going to yield. University-initiated commitments and activity. And then the last is we're working right now with the publishing community to get commitments from them as well. So we're trying to corner this in many different ways, but again, the federal government is the catalyst, but we're really going to try to work with these other stakeholders to get more movement at large. So, I just want to echo what the organizers of this summit have said, echo some of the things that Tom said at the beginning, and really encourage this group to identify these shared principles to guide your collaboration. And the Human Genome Project is really in many ways an inspiration for us in several different facets. But the one in particular that Warren mentioned was the Bermuda Principles, where a bunch of thought leaders in their field got together and they said, here are the rules of engagement. If you want to be part of this initiative, here are the 5 things that you're going to do. As soon as you create a result, this is how that result gets populated. A lot of sharing of information, a lot of collaboration. Their results were remarkable, but they had a lot to do with these guiding principles. This is a little bit more challenging. We don't have one discrete goal. We don't have one community that's self-organized under one professional society, et cetera. So we're going to have to work harder to make those bridges happen. But we can start at smaller scales. We don't have to go for the big thing, the Hail Mary all at once. We can actually develop work in your community, whether you work on alloys or nanomaterials, or maybe you're crosscut, maybe you do computation. Start bridging that community and moving it from there. So I hope that by the end of the day, or in the coming months, you do identify something specific, something that you'd be likely to share with us, and in any way we can to help, we will. But why don't I just leave it at that and say, I really appreciate everybody's willingness to be here, excitement for this initiative. We're really excited about it. We hope that in the next 9 months we have more that we could announce and talk about with this community. So thank you for having me, and I'll just, pass it on.